Hello everybody, welcome back. Today we're going to look at 6.3. We're going to investigate graphs of linear functions. Going to do a little calculator work as well. You guys have the Chromebook version of the calculator, so I will show you that link. You just have to be signed into your account. Don't browse as by guest or browse as guest. What you need to do is sign in, and then you'll be able to use the calculator if you haven't done so already. I'll show you how to do that as well. So let's look at some of the intercepts we talk about. We have an x-intercept. So the coordinate of the x-intercept where the graph line intersects the x-axis, so that would be right here. The y value of that is 0. Okay? 0. That's important. Okay? And the y-intercept, that's the value right here, you see in the second graph, or the first graph. The y-coordinate where the graph of the line intersects the y-axis, and the value of the x there, where you guessed it, it's also 0. Okay? So let's look at slope and y-intercept from a linear equation. So a linear equation is in the form y equals mx plus b. So the coefficient in front of the x value is your slope, and the value that's added or subtracted from the linear line is called the y-intercept. And that's actually given by b. And we'll talk about that in the next chapter. Right now we're just investigating it and learning how to plug it in the graphing calculator. So what I'm going to do with you, I'm going to show you how to do that on the graph calculator just as an exercise. So we're going to open up a graphing calculator. So mine will look a little different than yours, but for the most part it's the same. Okay? And again, I will show you how to do that in class. So we hit y equals. First, I'd like to clear the calculator. So to clear the calculator, you hit second function here. It's in the top left-hand corner. Hit second function. You're going to hit the plus sign, which gives you the memory. So we're looking at MEM. This is the calculator's memory. I recommend you do this before, if you have the handheld calculators, of course, but even in your own. So we hit 7. That brings us to reset. Then I hit 1, all RAM, and then 2 resets it, and it'll say RAM cleared. And then you can just hit clear on your calculator and you're ready to go. So the first one there was y equals 2/3 x plus 1. So I just want to show you how to graph that on a calculator because we're going to be using this a little bit. Definitely not so much in Math 10, but definitely in some of your other courses. So here's what I want to do. So we hit y equals. All right, and if you want to get a fraction here, you can put it in brackets, or you can put a fraction. It works either way. But to put a fraction here for your slope, what you want to do is hit math, and then you write till you get over to frac, and it's nd. So numerator, denominator. Hit enter, and it brings your numerator, denominator. So you put the 2 and press down, hit your 3, and hit right, and then you can put your x variable in here, and then plus 1. So we have this in the form of y equals mx plus b. This is again called slope-intercept form. We'll look at this more in 6.4. Then we hit graph. So let's talk about this first before we hit graph. So a way to graph this is you can start at the y-intercept. This here plus 1 tells you the coordinates 0 and 1. And to get a second point, you just go up 2, right 3 to graph the second point, and there you are. So hit graph. And there it is. Okay? It's as simple as that. And that allows you to graph on your graphing calculator. Okay? And we're going to learn a little bit more about this in class as well, but I just wanted to show you that right there. Okay? And if you want to get a value, so for example, if you wanted to see the y-intercept there, remember we said it was 1? Well, let's check it out. So we can hit second function calc, and you can calculate a value. So you can put any x value in, right? Any x value in, second function calc value 1, I apologize, and put any x value in, so we put 0 in, and there's your y-intercept, the one that we have in the equation that we saw before. Okay, we'll talk a bit more about this and we'll explain more in detail, but I just want to show you how to enter that into your graphing calculator. Okay, so let's look back and look at the investigation. So the slope is 2/3. Sorry about that. Slope is 2/3, and the y-intercept is, you can say the y-intercept equals 1. I like to show it as a point. 0, comma 1. Okay? There you go. And that's it. That's all we're doing. We're just making sure we understanding what they are. Here's another graph. Let's talk about this graph. We have obviously it's decreasing because the slope is negative. So the rise is down 2, the run is right 4. We have a y-intercept of 6, and our slope is negative 2/5. It's that easy. Put our slope in. We'll put in a negative 2/5. And our y-intercept, I like to show it as a point. You can say the y-intercept is, you can say 6, or you can show it as a coordinate. Like I said, I like to show it as a coordinate. It's 0 and 6. That's it. Okay? And you can see clearly it's going through at 6. Okay? Next we have, and this one here is a little different. It doesn't have a y-intercept, but that doesn't mean it doesn't have a y-intercept. There's actually a plus 0 here, right? We don't show it. 0 is said to be there. If you add 0, it doesn't change it. So there is a plus 0. So that means that the y-intercept is simply the origin. So the y-intercept is found at the origin, and the origin is 0, 0. Okay? As you can clearly see going through the graph at 0 and 0. The slope, we can say, is just 3, or you can say 3 over 1. Both are acceptable. You can say its slope is equal to 3 or 3 over 1. Okay? I'm going to fix that, sorry. So, enter that. Sorry, I'm going to use the slope is 1, or sorry, 3 or 3 over 1. Both are acceptable for slope. Usually you don't see it 3 over 1, but if you want that for the rise and run, they're equivalent, right? So it's a slope of 3 doesn't mean just go up 3. That means it's up 3, right 1. Okay? So you can see right there at the origin, and you went right 3, up 1. Okay? So just be mindful of that when you're working through these. The next one, we have a negative 2/5. So there's this, or sorry, a negative 5/4. So that is your slope right there. And your y-intercept is at 0 and negative 2. So 0 and negative 2. Okay? Sorry, just fixing it up, so I like to have a larger line there. Okay? And there we are. And you can clearly see it's going through a negative 2, and you would go down 5, right 4, and there you are. Okay? Next one we have y equals negative x. So the slope, there is a slope, and that slope is negative 1, right? If a number doesn't have a coefficient and it's negative, that means the slope is negative 1, okay? Or negative 1 over 1. So what it means is, it means that you're going down 1, right 1, down 1, right 1, all right? Again, there's nothing being added or subtracting to this, so what this means is plus 0, so there is a y-intercept, and it's going through the origin again at 0 and 0, so we have to be mindful of that, okay? Just be careful not to miss that. Because it is there, all right? The next one, again, we have nothing at the end, so there is a plus 0. Don't forget that. So that means the y-intercept is there. It is 0, 0, the origin again. And our slope is 1/2. So we just take our slope out, all right, and it's equal to 1/2. Okay? And the last two are the two special cases that we talked about on the first day when we did 6.1. This one here is a horizontal line at y equal negative 2. So that means we don't have a slope. The slope is actually equal to 0, as you guys recall. So all the slopes of that can be 0. And the y-intercept is whatever it's equal to. So if it's equal to negative 2, it's going to go out through the point 0 and negative 2. So the y-intercept here is negative 2. It's whatever the y value is for your equation or your linear function. Okay? This one here is interesting. We have x equal to 3. All right. I'll get you to draw that. You can't draw that on our graphing calculator. So what I'm going to do is I'm going to bring up Desmos, which allows you to graph things that aren't functions, such as x equals 3. So it doesn't have to be in that y equals mx plus b form. So I brought up the Desmos program. The Desmos program is found at desmos.com, desmos.com. Okay? And the equation is x equals 3, so you can put the 3 in there, and there you see your line, okay, at x equal to 3. You can see it going up and down here. I'll make it a different color so you can see it. I should have left it. All right, see the red there, and there's your line. Okay? So x is always at 3 there. All right? So I'll snip that so we can have that for our graph. Again, we can't do that on a graphing calculator. At least I don't know how to do it, but I don't think it's possible. I think everything has to be in y equals form. Okay? All right, so I'm going to grab that now. So our slope here is going to be undefined, if you do recall. Remember, we have an undefined slope because we're dividing by 0, right? The run is 0. It doesn't go left or right any. So, and our y-intercept would be none, right? Okay? Doesn't never crosses. It's parallel with the y-axis. All right? So the graph of the equation y equals mx plus b, your slope is going to be m. I mentioned that before, and your y-intercept is given by b, so it's going to be the form y equals mx plus b. This equation, y equals mx plus b, is known as slope y-intercept form of the equation of a line. So let's graph this like we did there without using a table of values. So just looking at the equation itself. Okay? So what I've done is I've started at 0 and 3, and I went down 3, right 5, and I've drawn a line down through. Okay? So we'll do the next equation. It's y equals, the b part, y equals 3x minus 2. So the minus 2 represents the y-intercept. So there's a point at 0 and negative 2. Okay? And the slope is 3, which means rise 3, right 1. So that means we're going to go up 3, right 1. We're going to have a point at 1 and 1. There it is. There. And then you're going to draw a line through those two at y equals 3x minus 2. And it goes right through at the 2 points. And there you are. So I'll take a picture of that for us. Put that into our graph so you have it for your notes. Make it a little bit smaller. There we are. Next one is we're going to determine the equation of each line, so we're going to do the same thing. This isn't too bad. Okay. So the equation of this first line, remember, you want to find 2 good points, so I would be picking the y-intercept, which is 0 and 2, so its b value is going to be 2. And another point here, you can see it going clearly through at 5 and 1, so it's down 1, right 5. So your equation is going to be down 5, which is minus 1, right 5, which is 2. There's that equation. So there's your slope, multiply that by x, and then of course your b value is just 2, the y-intercept, and there it is. Let's do the next one. I'll steal this. Same thing. We start at the y-intercept, so we know that we have minus 1, right? So that's going to be the end of the equation, and we go from there. We go up and find a spot. You can clearly see it's going right through at 3 and 3, so that means up 4, right 3. So that's your slope, 4 divided by 3. X. So the equation is y equals 4/3 x minus 1. All right, and some homework there on page 356, 1 through 7. Thanks everyone for watching, and we'll see you again soon.